Hello, let's see how one of the challenges from 2019 Hitcon competition could be solved. The challenge is quite interesting to me because it actually consists of two things that I like, one being reverse engineering, the second one being Lego bricks. So the challenge is EV3 Arm, and what we are being given in this challenge is this picture, which I guess goes a little beyond the screen, and also we are given a link to some YouTube video, and when we open it we can see a Lego bricks, Lego Mindstorm, and yeah, let's see what's happening. Not that long, the video is just 50 seconds, but we already can see that this arm is drawing a flag. So we can assume that we'll have to find out the flag, the rest of the flag. You can see the video is almost over. Okay, so it's only drew a Hitcon and the rest of the flag is of course not visible. And what else we are being given here is this RBF file, which is, I can assume, some kind of file that represents the movement of this robot, and we need to extract the flag from that file. Okay, and the file is actually a binary file, so there's nothing readable in this file that we could actually get, but there is this EV3 tree visualizer which can be used to pass this file, and what we'll get is a textual representation of what's in this file. And actually I think this tool changed a little bit from the moment I was solving this challenge during the competition, because right now it's a bit more nested structure. Before it was a bit more flat, and I think the order is a bit different of those items in the list. But nonetheless, there is a tool that can take this binary file and give us something that is more readable in text form. And I have the one that I used during the competitions. So this is the file. It actually has more or less the same data, but the nested parts are a bit less visible here. There's only like a fork and one line, here are two lines and a few more. And if we analyze this file and look at the video, we can actually identify what's being done here. So the port motor B is responsible for lowering the pen and taking it up. So if there will be -15, the pen will be put down, and +15, it's moving the pen up. A is responsible for movement of the arm. So basically in here the arm will rotate 720 degrees, and it will be to the right. If we look at the position of the arm, here it will be to the left. And we also have port C, which actually is responsible for movement of the whole robot. So in here we'll put the pen down, we'll draw a line, or actually we'll draw we'll rotate the arm 720 degrees to the right, which, because the pen was down, we'll draw a line. Then we will put the pen up. We will move to the right by half of the dimension, and then we'll put the pen down again, and we will move the whole robot to the right by like some 2 rotation and with speed 70. We don't care about speed here, we only care about the sign. Okay, so those lines will draw as a part of H. So it will be like a vertical line and the horizontal one. And then again, those lines will draw the rest of the letter H. And then we'll move again by some rotations to draw another letter. So this is the description of the letters of the flag, and we just need to find out how to extract it automatically. Of course, we'll not draw it manually. We could, of course, draw some of those letters to find out if it actually makes sense. But yeah, it does. So we can write a short Python script. So what it does actually, it's just, where does it start? It starts here. So we just open the file, we get some preparation. So basically we'll be in the not drawing state. And we have some function to move and draw a line. And basically we go line by line, then we just print the position, and if it's port B, and if it's speed -15, then we'll set drawing to true, because the pen will be moved down. And if it's speed 15, then we'll set the drawing to false, because we'll be moving the pen up. And then if it's port C that is in the line, then we'll extract the rotation parameter, which is done by this regular expression, and then we'll just save the value. We have some multipliers, so it's basically a bit more value is being actually done here than what's in the file, because in the file you can see it's like 2 and 1.5. If we would actually use that as a pixel, that would be very small movement. So we just multiply by like 15, I think, here. So it make it a bit bigger. Okay, and then if there was a speed with minus, then we'll just convert, because we'll be moving backwards. And then we just move. And we pass this pixel parameter and drawing. So basically, if the drawing was set to true, we have to draw a line. So let's see the move method. So basically, if the drawing was set, we'll draw a line with those new values. Like we only care about horizontal axis, so only pen X is being modified here. And then we modify the new position of the pen X position. Okay, so that's one, and we also have some printing done. And if it's port motor A in the line, we extract the same value with regular expression, but in here the values are a bit different, because we can see there's like 720, so it's like more rotation than in this port motor C, and we can see it's like it looks like it's in degrees. So what I'm doing here is actually I divide by 360, so I want to have how many full circles the rotation is done, and multiply it by my multiplier, so 15 in this case. And in here the directions are different than in this one. So if it's speed with minus, then we change the value. So basically, if it's not, so we have normal speed, then we'll not rotate, we'll not change the pixel. But if it's not, then we'll change the sign. And then we draw a line here. So it's so it's actually similar, but we'll be changing a y coordinate here and not x coordinate, but more or less it's the same. So we have a new y which we use in draw the line if the drawing is set, and then we apply the new position that will be used in the next, and we just move to the next line. And that's the whole solution. And if we run this script, we'll get at the end the flag PNG will be saved. And if we look at this file, we actually get something that looks like a flag, but some characters are not really readable. Well, we know that it's N because it's Hitcon, but what is here, what's like, yeah, there are some unreadable characters, and it is due to those forks. So basically, if I read correctly about this format, you can move 2 engines at the same time. So there could be like two movements at the same time, which produce a more complex lines than just horizontal and vertical ones. And we would actually have to implement that to make make the correct drawing. But yeah, we don't actually need that. We have something that looks like a flag. We know that this is N. So if we look somewhere, this symbol, the same, we'll know that this is N. So it's again here. So it's Hitcon, not. Well, this looks like just. It might be just. So if it's just, this is the same U and S. So it would be use the printer. This is really readable. So we can actually have an educated guess that the flag could be Hitcon. Why not just use the printer? And actually that's the flag. So if we enter that into the box in the competition, during the competition, we would get the points. So we didn't have to actually implement any complex movement. Those verticals and horizontal lines were enough to solve this challenge. And yeah, I guess that's also something sometimes can be done during the competition. You don't have to implement everything, just have enough to do an educated guess what the flag might be. And yeah, that's all. That was one nice competition during Hitcon 2019. I hope you liked the video. I hope you learned something, and if so, yeah, hit the like button and subscribe, and see you next time. Thanks.